it, and then I'll tell you what you can really do, okay? All right, so we're going to do y squared, treat it like u squared, where u equals y, right? Okay, so the derivative of u squared is 2u, and the derivative of y is dy dx, or y prime. But remember, we always use y prime. Of y. Yeah, right? Is it not? The derivative of y is the derivative of y, because it's with respect to x. It's with the x involved. If y is, I mean, you all agree that y equals x, dy dx equals 1, right? I don't understand. We do this like 1,000 times a day. Y equals x, take the derivative of y, and we get dy dx, right? Derivative of x is 1, done. We're not doing anything that we weren't doing, we're just doing it a little bit differently now. Okay? But we've done this a million, zillion, quillion times. There's even a word. Right? Billions. Okay? We're taking the derivative of y, which, as Allie said, is the derivative of y with respect to x. Okay? Alright, so u is what? Y. Okay. Now, I know that's confusing because we've never done that before. Okay? But here's what you can think about doing if you can remember to do it. Instead of making all your y's u's and then going back and putting in your y's, what you can do is you can say, okay, I'm going to do this regularly, but I'm going to have to remember to add a dy dx every time I do it with the y. So I'm going to do it regularly, which is just the pull the 2 around as a power rule, and then I'm going to turn and add multiply by dy dx. Okay? Because that's essentially what we got right here when we did the chain rule, right? Yes, Laura.
What makes it? Okay, so the fact that it's equal to x makes it.
No, it's the fact that it's y squared and not y that we can't just say, oh, well, the derivative of y is dy dx. Because we've done that. We went from y to y prime, right? Okay, that's what we're doing, except now we're going from y squared to y prime, and that makes it more complex. Yes, Mom?
So there's change in the origin of the reflection. Why don't you just take square root of y?
Because we have this and this. Which derivative do you want? No. Then you're going to have 2 different derivatives. We want 1 derivative. So we have to leave it. That's the whole difference. That's why we can't do this and get this to be y equals something explicitly for x, for y. Okay? All right, so now, what does dy dx equal here? We're doing algebra now. How do I get rid of something that's multiplied? I divide it. So here I go. And there's my derivative. Okay? They're going to look weird because they're going to have x's and y's in it, but it's because of where their starting point. Okay? So let's try another one. Find the slope of the circle, x squared plus y squared equals 25. If you wanted to put in that equation, you'd have to put it in like this, where y equals the positive value, just to have the graph in front of you, which is always nice to have that. Okay, so that's a circle, and it's not supposed to have this gap, it's just the graph thing. Okay, so this top half in the calculator is the positive 25 minus x squared, and the bottom half right here is, of course, the negative. Okay, but we can't do 2 different derivatives. We don't want 2 different derivatives. We want 1 derivative. Okay, so here's what we're going to do. Take the derivative on both sides. Okay, here we go. Derivative, derivative. All right, here we go. What's the derivative of x squared? What? Okay. What's the derivative of y squared? 2y, you're close, dy dx. Okay? So you do it regularly, like if it was an x, and then just tack on and then multiply the dy dx. What's the derivative of 25? 0. Okay? Now we are, that's calculus. Now we're going to do algebra.
Wait, with the whole thing you ever did?
Well, dy dx. What whole thing are you referring to?
I thought, well, if we times, no, I thought you had it as one. I didn't do the whole thing.
Yeah, I have it multiplication. Okay, so now what? How do we get dy dx by itself? Do what? Subtract 2x. That'd be a good start. All right, so we have 2y times dy dx equals negative 2x. And now what? Divide by 2y again. And dy dx, the derivative equals negative x over y. Okay? Now we are interested in at 3, negative 4. So we're going to draw our little line like we always do. What did I say? Negative 3, 4? Okay. 3, 4, sorry. Okay. Short-term memory's gone. 3, negative 4. Okay, remember x is first, y is second. Okay, so x is 3, so that's going to be a negative 3 when I plug it in, right? Y is negative 4, so my slope is 3/4. Okay, so this one would be easy one to check out. Sometimes it wouldn't even be possible because of our graphing, but let's say, all right. So we are, what were we supposed to do? Right, find the slope. Okay. We weren't supposed to do this, but what's the tangent at 3, negative 4? Y minus plus 4 equals 3/4 x minus 3. Okay, I'll put that in the equation just so we have it. All right, so square roots 25 minus x squared, that's the top half. Let's see that, that's not pretty good. Let's try that. We'll go back to the regular window. Okay, so there's the top half. It's not very circular because of my I don't have a, let's do a square number 5. All right. Okay, let me put the top one in. Now that's my bottom one, negative radical 25 minus x squared. Okay, and then I'm going to put my tangent line in, so negative 4. Oh, man. Like 3.
Wait, so you got those equations just by getting y by itself?
Yes, yes, I did. Plus 3/4. I'm going to do, just in case the calculator decides to do something weird, and then x minus 3. So that's my tangent line. Okay, so there's my bottom half of my circle, and here comes my tangent line through 3, negative 4. Okay, so here's 3, negative 4-ish right there, and that certainly is a reasonable tangent for that thing, right? Okay. So you can verify some of them, but a lot of times the non-explicit equations are hard to put in your calculator, okay? So just keep that in mind. You can check them out. It certainly makes more sense. But when it says to find the slope of the circle, that means the tangent at that point, okay? So the language is not going to change. It's just the equations are going to be like, what is that? Okay. Again, we have a y under a radical, and we have a y over there. So rather than solve it explicitly for y, because this x is going to make it complicated, we're just going to do implicit differentiation, which is derivatives of both sides. Okay? So that's with the prime thing. I'm just differentiating both sides. All right, now, before we get too far, this right here, I'm doing the first step, and then I haven't really dealt with this because it really hasn't been a problem. I haven't really had more than one factor, so that's why I haven't gone there. I'm going to have it in one right now, so we'll come back to it. Let's go. I can switch this so we can see it both here in a minute. Okay. All right, so I look at this and what should I see? Starts with a P. Product. Okay. So I'm going to rewrite this with the product being clear. All right. And then this is just a subtraction rule, so that should be a piece of cake. Okay. So the product rule. Product differentiation. Derivative of x times y. That's a derivative. Plus, what's the rest of it? Right?
X, y,
Very good. Okay, so that's the product rule. All right. Let's go ahead and do this over here, and then we'll come back to that. What's the derivative of 4x squared minus 3y? Maybe.
8x minus 3 dx.
dy dx. Yeah. Okay. Very good. She pretended y was an x, so it's a 1, but then remember when you have a y, you got to tack that on because it's really a chain rule thing. Good job. Okay. All right, so what's the derivative of x? So y to the 1/2 plus x. What's the derivative of y to the 1/2, Brooke?
So what are the 1/2 of the? Like even the derivative of it?
Yes.
You said that's right. 1/2 y to y negative 1/2. I'm there. I'm sorry.
Don't forget
Oh. No, dy.
dy dx. Whenever you take it, and it is with respect to y, if it's a y involved, you're really using a chain rule. You don't have to like make a big deal out of it. You just have to remember to add or really multiply by dy dx. Because it's a chain rule. The derivative of the inside, Blakely, is dy dx. Okay? All right. So this is kind of a mess. So let's see what we have. Blakely knows why I have a singular derivative, right? Okay. So I have y to the 1/2. What's this mess? How would we, I guess, parentheses, I don't really need the parentheses, so I'll put the 1/2 out front, right? And what else do I have? X and y to the negative 1/2 dy dx. Okay? Dy dx. All right. Now here's where I want to, what happened to my,
Is the dy dx attached to any specific term?
yeah, it's attached to this term, or it's attached to this term. Not like, no, not necessarily. It's multiplication, so we can kind of mix those around. I started the recorder. What happened to it? Is it recording? It is? Oh, okay.
Wait, so you got the dy dx just because you've gone and derivative of y?
Yeah, it is. Okay. Okay. I'm sorry, what?
You got the dy dx just because you're finding the derivative of y. So whenever you're
That's right. That's right.
Then I'll put the end.
Yes, just tack it on to the end. Yep. And it is multiplied. Even when you add it on, you're really multiplying it. Okay. Listen.
The 3 in front of the dy dx.
That's multiplication.
So,
Is that what you were going to ask? I just don't usually use the dot if I don't need to, but you're welcome
well,
to if that helps.
So it'd be like 3/1 times dy over.
Okay, yeah. Whenever you have an algebra equation, and you're, say you have 5x minus 2 plus 8x equals 3x minus 1. If this x, and this x together, you're going to gather them all to some side, right? You might want to, let me just get rid of this. Let's say it was this. You decide, okay, which way am I going? Am I going getting on the left or getting on the right? It's just a personal preference, right? So where would you go, left or right? Most of us will go left. Okay, so that's what I'm going to do. I'm going to put my dy's on one side of the equation, my dy dx. So this is all going to stay here, 1/2 x y to the negative 1/2 times dy dx. This one's coming over, so what's it going to be over here? Plus 3 dy dx, okay? All right, this guy is going to go to the right because he doesn't have a dy dx on him, right? So what's he over here? Negative y to the 1/2. And this guy is already over here, so he stays 8x. Okay? So it's algebra. You're just concentrating on adding, subtracting, putting your dy dx on one side. Okay, so now, once you have that done, you're going to factor out the dy dx. All right, so dy dx gets factored because that's the only way to get one of those guys. All right? And you'll get really good at this because it's the same thing over and over and over. All right, what do I have left out of this term if I take my dy dx out? Very good, Taylor. And what do I have left over here if I take the dy dx? 3. Okay, so see, you're not going to really worry about that 3 over 1 really for the most part. Okay, so now I have it factored, and what do I do once it's factored to solve for dy dx? By 1/2 x y to the negative 1/2 plus 3. We got some complex going on here, so we'll have to take care of that. Plus 3. I'm going to go back to single page here. All right. Okay, giants. This is really bad. Negative 1/2. Okay. So now what? I got a 2 down there. That's an extra. And remember, I really have. Let me rewrite here. I have this, which is cool. This is okay. This is complex. X is okay. Y becomes down here 2, right? Because it was y to the negative 1/2 plus 3. 3 is okay. So you see what the problem is. There are 2 things that are extra. So we're going to do like we always do. We're going to multiply by those denominators, top and bottom. Because we're really just multiplying by what? What is this? 1. Okay? Now remember, you get to distribute. Okay? You can't just do the last thing. All right, let's take care of the bottom first because that's where our problem is. This times this, what is that? 1x. Very good. Okay? This cancels with this. All right. Plus this times this is y to the 1/2. Okay? Very good. All right, this times distributed, we got a y to the 1/2 and a y to the 1/2 and a negative and a 2. So that's negative 2 what? Y, good. 1/2 plus 1/2 is 1. Okay, and then what's that? 16, that's an x, y to the 1/2. That's pretty, isn't it? But remember, our equation was not pretty from the beginning. So our derivative is not going to be sticky. It is done. You can, if you'd like, x, y, x, y. That would be okay too. I would take either of those answers.
We did the 1 and put in the x.
Nope. But I would take any of those. Did I lose anybody? Anybody have any questions? Okay. These aren't going to be nice looking answers for the most part. Okay. What's the matter, Ella?
She doesn't have her stuff. She's still down slowly.
I need to go buy one, girl.
Oh.
This is the wrong one. This won't work because it's a sophomore. It's no one wants those. That's why it's here. You'll see one. All right. Yes.
So when you multiply that, you add the
Yes. Yes. That's that rule. X to the second times x to the third is x to the. There's 2. There's 3 more. There's 5. Okay. Yes. When you're multiplying the numbers, you add the exponents. Yep. Okay. All right. Ellis? Is Katie done yet?
Yep.
Okay. Woo. All right. Okay, here's an ellipse. And we got, I might have to look at those, but we spent way too much time on homework, I'm thinking. All right, I'm going to take the differentiate at each side. All right. Okay, what's the derivative of x squared? 2x. Now, how do I find the derivative of xy? Product rule. So I'm going to put that in parentheses right now because everything behind it until I get to y squared is going to be subtracted. If I don't do it now, I will not remember it. Okay, what's the derivative of x? Times y plus x times what's the derivative of y? Yay, okay. That's the product rule. Product rule. Okay, what's the derivative of y squared? dy dx. Very good, Ella. The derivative of 9? Okay. So we have 2x minus y minus x dy dx plus 2y dy dx. The parentheses to me are very confusing. I don't like them anymore at this point. If I'm going to kind of put my dy's together, I don't want all those parentheses. They just mess me up, especially when you got a subtraction in front of them. All right, so you want to leave the dy dx's on the left again? All right. So, negative x, dy dx plus 2y dy dx equals what? Good job, Taylor. Negative 2x plus y. Okay. Now, what do we do to get one of those dy dx's? Factoring. Dy dx. Who knew factoring was so important? The algebra teachers don't know that. Clearly. Right? All right, so what's dy dx factor down there? Negative x plus 2y, and see, this is the same old, you're going to get like, oh my gosh, I feel like they do this all the time. You are going to feel like you're doing the same thing all the time. So what do we have? Negative 2x plus y over, okay, and we're going to, not too bad looking. Yes. Okay. Wait. What time are we on here? Oh, okay. I want to make sure that you don't have any seconds to write it in the ones I gave you. 6 seconds. Okay. Oh gosh. 6 seconds. Wow. How many got? I know, we had a second derivative, which I didn't ask you to do, I don't think, so we're good. You should be okay. Okay, do it by hand. Do the bells by hand. On these days, I'll try to. All right.